Hello everyone, hope you are doing well. Today we are at our lecture number 9. In the previous lectures, we learned the details of primary and secondary structures. We also saw some measurements and we saw them in the StereoNet, and we also showed you the locations while we are moving from one place to another place. That was kind of an introduction of how to get things done in the field, or how to get the basic elements done in the field. In this lecture, what we are going to learn, or what we are going to do, to be very specific, is we will map one of the quartzite bands, and we selected the first quartzite band that we have learned in the first week. In order to map the first quartzite band, we first start from the Chitrakoot hillock, and then slowly we will progress towards the Subarnarekha river and see how this quartzite band is disposed in the field. So, in this mapping practice that we are going to learn today, it has some limitations, because I tell you again that mapping in general must be performed in the field. Doing mapping online is kind of a vague thing. You cannot do that. You have to go to the field and see the exposures, take measurements, plot them in the topo map or in a plain paper map, and so on. Now, because this is an online course, what we are going to do, we have to miss a few of the important aspects of mapping, and two are very important out of these. One is locating yourself in the topo map, that is where you are in the map. You have to locate where you are measuring the data, and vice versa. Now, these are done by two methods, back bearing and front bearing. We hold the compass, we take bearings or some orientations that from a particular object where we are in a particular direction, or where I am with respect to a particular object, and these are essentially known as back bearings and front bearings, and these two are learned in the field. Unfortunately, we cannot teach you this online. Instead, what we have done, we have seen the topo map, and in each and every location where we will be doing the measurements and doing the mapping work, we will locate this place in the map with a red circle. We will tell you where we are exactly on the map. That we have practiced in the field, but again unfortunately we cannot show you that. And then with the TAs, I will proceed following the quartzite bands, and one after one we will plot the locations, we will plot the data in the map, and you will see how the map is being progressed. And one important thing that we have done, because we wanted to map the quartz band, so we also had to measure the thickness of the quartz band. In order to do that, we used some measuring tapes, and sometimes we took some footsteps, and that we have calibrated with the standard measurements. So, this process is also not shown in the field, because this you learn in the field with your instructor, and we cannot teach you this during the online courses. So, the way you should look at this lecture is that we are taking measurements, mostly the data of S0 from one point to another point to next point and so on, and we are taking a lot of data. In the map, because it is a small area, so we did not plot all the data that we have measured. We plotted some representative data, that means dip and strike of the particular location. But when we do it in the StereoNet, we added all the data, and while we will be showing you the topo map with the map of the first quartzite band, you will also see how in the StereoNet we are plotting the data, and it is slowly populating with more number of data while you are progressing with the mapping. This area, this region is known as Harindungri. This is how the local people call this place, and this is again within the Chaibasa formation. So, give you some sort of orientation, this is the north side. I am facing north in this way, and then this is the east. Towards this side is the south, and if we travel a few kilometers from here, we will again get the Subarnarekha river. So, further to this side we have Singhbhum shear zone, in the middle we have Chaibasa formation, and on this side, that means towards the northern side or northeastern side from this place, we have Dalma volcanic. So, we are in the middle of the metasedimentary sequence. In this particular region, as you can see, I am standing in one of these places. We have 3 quartzite bands, and I am standing on the thickest one, and this band is synthetically deformed with the regional deformation. So, you can see that I am standing on a hillock which locally known as Chitrakoot hillock, and then this band of quartzite, we will identify it, is moving this way, and then it hits river Subarnarekha, then it crosses river and then makes a slightly gentle fold and then disappears on the other side of the river. Now, this place is unique for many things. As I said at the very beginning, that this place is of low metamorphic grade. So, this rock, which is quartzite, it still retains the initial structures. We will see bedding planes, we will identify them. We will also identify the younging directions through some syn-sedimentary features. We will also figure out if we see some cleavage planes here, and together with some very late stage deformation, for example tensile fractures and so on. But to give you a very basic idea, that you can see that that is the general trend of this bedding that we are looking at. So, it goes this way and this side. We will also see that this bedding sometimes is faulted, it displaced across its strike line, and these are very late stage features and may or may not have some implications of the regional tectonics, and that we will learn when we will do some regional mapping and other things. Yeah, so we are following the youngest and thickest quartzite band, and we are measuring the deep and strike of the bed of this particular thickest quartzite band. So, we measured this Chitrakoot hillock, and then we have measured on the other side of the road, and now we have crossed the road, we have crossed a little canal. In front of me, this particular quartzite band had a little offset, we will see it on the map, and here we will again take the measurement. So, that is the plan, we will see that whether this layer is folded or not. In order to do that, we have to continuously measure dip and strike of the bed. So, here you see the beds are going like that, it is steeply dipping. So, we take a measurement here, we did take some measurement on that plane, and now this is some beautiful bedding planes exposed here and here, and we will take the measurements here. So, Rajiv, would you please come and do the measurements and note it. So, these are the bedding planes, you can figure it out, and we will take the data from here. Take from here, it is good. What is the strike here?
090, that means it is in east direction, and the dip is 65 degree towards north.
So it has turned.
Yes.
Very good. In this cliff, which is almost vertical, and the rock type, as you can see, this is quartzite, and you can see the extreme of brittle deformation that happened here. One major feature that you have already observed, I believe, is this dike, quartz vein dike, which is vertical, and on the top of that you also have noticed probably two sets of conjugate shear fractures, and these shear fractures are very important in understanding the late stage orientation of principal axis of stresses. But again, what I wanted to convey, that we are also identifying the bedding planes in these places, and we are also looking at that what are the dip and strikes of these bedding planes in order to understand the deformation of the single thickest quartzite layer in the Harindangudi village. So, we are following the same quartz band, we are approaching the river Subarnarekha, and as you can see in this exposure, I have just measured one, it has a lot of quartz dikes, quartz veins, and we are taking measurements. For example, I just meet one here, let me take the measurement as well. So, I am mostly taking the way, so the quartz bands are, as you can see, that they are vertical. So, I am taking mostly they are trained, and they are more or less constant, orienting around, ranging from 150 to 110. But again we are measuring the bedding planes, and you can see here the bedding planes are exposed very nicely, and you may see some traces of the cross beds. So, I probably avoid measuring that one. I find a very good one here, this plane. So, I measured that, and this is how we are taking the data. Of multiple bedding planes and trying to generate a robust data set of this quartz band, so that quartzite band, so that we can understand that whether this band is deformed or not. But I tell you, I give you a clue. We already see that strikes of these beds are changing. So that gives you a clue that it is folded somewhere, and we have to figure out if these are all right or not. So we move to the next location. Wow, so we see a quartz strike here as well. So let me take the data of it first, and you see this is not a single quartz vein, there are multiple veins. So that means multiple fractures have happened. Now of course you need to do a geochemical study to understand whether they did happen at the same time or at different times, which is not our purpose, but if you like to do, you can look at it. So the orientation here is in the same range, so it is 120, which is okay. And we are seeing the bedding planes here. We are seeing the bedding planes here. These are not the traces of the bedding planes, these are actually traces of the joint surfaces, because I can understand these are bedding planes because I see on the other side, the profile section, I see the traces. So I find this a good place to measure the deep end strike of the bedding plane of this quartzite band. And I always apply right hand rule while measuring the deep end strike, in particularly strike. Here it is 225. And the deep is 62 degrees. Let me note it down to my notebook. So we have almost reached the river. It's about 100 meters walk from here, and then I'll see you again at the river bank, and then I can show you the entire quartz band. So let's go. So, we are again at the bank of Subarnarekha river on the northern side of the river, and I am standing at the middle of the thickest quartzite band which we have been following in the entire day. So, we measured the data from the Chitrakut hillock of Harindungri village, and then we followed the quartzite band. We measured the dip and strike at regular intervals of the bedding planes, and now we are here. Of course, we cannot go further to that side because the flow of the river is very strong, but we still can measure the data here along this. You can see the bedding planes are like this. The orientation here grossly I can measure. It is 250 degrees. So, we will further go ahead, measure individual bedding planes, and finally what we will do, we will collate all the data, plot them on the stereo net, and we will figure it out if we are visualizing a fold there or not, and if we see a fold, then that would be an interesting finding for this region. So, we spend almost entire day tracking this, and let me go ahead and measure the data. So, we have done with this lecture, and I hope I could give you some basic ideas of how the mapping is done in the field. I understand it is not done very properly, but we have to accept the limitations of online lectures. What we have seen in this exercise, that we plotted the quartzite band in the topo map, first quartzite band, and we also collected the data of the S0 which are inside the quartzite band, first quartzite band, and then we plotted all the data in the stereo net, and we saw that it is a folded layer. The first quartzite band is folded. The fold axis we saw is not really similar what we have seen in the Ferrighat. That tells us something, that the regionally what we saw in Ferrighat is different what we observed today in first quartzite band. We did not show you, but I will show you in the map. We have equally plotted, or we practiced the same with the second and third quartzite band. So, you actually will see the map of second and third quartzite band. We have done it by ourselves. We did not show you while we are doing it just because of the time constraints, but we followed exactly same process the way we did it in the first quartzite band. And we see that both first and second quartzite band and also third quartzite band, it does not have too much exposures, particularly for the third quartzite band, but we still can guess and connect some dotted lines to get the general idea that how these three quartzite bands are deformed in this region. At the end of this lecture series, we will take all these data, we will compare with Ferrighat and some other regions and figure out the overall deformation of this region. Till then, thank you very much. In the next lecture, we will talk about ductile deformation that we see in and around Ghatshila. Thank you.